Hello. Today we'll talk about forces. Forces is a topic related to physics. We have some objectives today. By the end of this session, you will be able to define what's meant by static and moving object and how can you differentiate between them, and also how to draw the distance time graph for each. You will be able to define what's meant by force and what are the types of forces, and also you will know that the measuring unit of force is Newton. You will be using this formula, which is F equals m times g. F is the gravitational force or weight, m is the mass, and g is called acceleration due to gravity. And we will solve some mathematical problems related to it. We will study a law which is called Hooke's law, and we'll verify it practically. And through this experiment, we need to identify the independent, dependent, and the control variables. According to the level of difficulty, you can classify the level of your understanding at the end or by the end of this lesson. So all of us must be able to define what's meant by static and moving object. We should be able to define or describe the distance time graph for static and moving object, mention the measuring unit of force, use the formula F is equal to m times g, identify the different types of variables in Hooke's experiment or the spring experiment. If we have a deeper understanding, you will be able to compare the distance time graph for static or a moving object, whether it's moving with uniform or non-uniform speed or velocity. You will be able to convert mass from grams into kilogram. You will learn how to do it just by divide the mass in gram by 1000. Then you have converted it into kilogram. Also, you will be able to calculate the weight by using the formula weight or F is equal to m times g, in which g is equal to 9.8 meter per second squared. Also, if you have a deeper understanding, you will be able to convert from centimeter into meters just by dividing the number in centimeter by 100. You will draw correctly a label diagram for the extension was or versus force. So you will be able to represent Hooke's law graphically. And finally, you will identify the control variables for this experiment. If you have a much deeper understanding, this is called stretch, you will be able to explain why the straight line graph verifies Hooke's law. This is called directly proportional. You will explain what happens if the spring exceeds the elastic limit. You will describe how errors in measurement could affect the results. And you will conclude or find the gradient or the slope of the graph and it will be equal to something which is called K, which is called the spring constant. Finally, you will predict what would happen if the mass continued increasing, if you add extra masses in Hooke's experiment. So you need to evaluate yourself at the end of this session against these targets. Okay, so let's start. So the first part, what's meant by static object? What's meant by static object? If we have a reference means a point, something, and you are just standing here at a distance of 1 meter between you and this reference. And as time passes, we have just started the stopwatch, so the time is 0. Then after 1 second, after 2 seconds, after 3 seconds, the distance between you and this object just remained the same, 1 meter. So if we just try to organize everything that we have in a table, this is the distance or the displacement between you and this reference and time. As you can see, when time was 0, the initial distance between you and the object was 1 meter. After 1 second, still 1 meter. After 2 seconds, it's still 1 meter. After 3 seconds, still 1 meter. In this case, your state is you are static object. You are at rest. It means that your speed is 0. This means that your position doesn't change as time passes. This is what's meant by static object. So how can we write this answer? I will just copy the answer just to save time. So for this question, the answer is static object is an object that is not moving and stays in the same position, or it is. I'm at school and there is alarm. Okay, I will continue. A static object is an object that is not moving and stays in the same position. Okay, so the second question, what's the moving object? We will do the same. We will have the same frame of reference, and this is the object. When time was maybe 0, the distance between this object and this reference was 1 meter. After 1 second, this object just moved another 1 meter. After 1 more second, this object moved another 1 meter. After another second, this object moved 1 meter, and so on. So if we try to arrange everything in a table, you will say distance and time. So when time was 0, the initial distance was 1. After 1 second, this object just moved 1 more meter, so the total distance till now is 2 meters. After 2 seconds, the object just covered another 1 meter, but this object covered 2 meters before, so it will be 3, so and so on. So after 3 seconds, it will be 4. After 4 seconds, it will be 5, and so on. So this means that as time passes, the object position changes with respect to an object or reference point from which we can measure that distance. But as you can see, the position may be changed by a constant or a fixed rate or by a random and changeable rate. In this case, the object is moving with uniform velocity or non-uniform velocity, uniform speed or non-uniform speed. So what will be the answer in general for a moving object? So the answer is, for a moving object, it is an object that changes its position over time. As time passes, its position changes. For the third question, describe a distance time graph for a static object. We can use the data here, by the way. Can you see this data? We can use it. So distance, it is the value which is written over the y-axis. Time, the second part, it is the value which will be represented over the x-axis. So this is a graph, this is the y-axis, this is the x-axis. On the y-axis, we will represent the distance covered by the object in meter, and over the x-axis, we will represent time taken by the object to cover this distance in seconds. So for time it was 0, 1, 2, 3, 4, and so on. As you can see for my example, the distance between the object and the reference just remained 1 meter. So this is 1 meter, 1, 2. So 0, we will have something which is called order pair, which is x coordinate and y coordinate. Time and distance, 0 and 1. This is the first order pair, 0 and 1. The second order pair is 1 and 1, 2 and 1, 3 and 1, 4 and 1. As you can see, as time passes, the position of the object doesn't change. So now you can describe the distance time graph for a static object. So it is represented by a straight line which is parallel to the x-axis or to the time axis. You can call this axis, this one, as x-axis or time axis. So let's copy the answer. By the way, you can just draw the graph and then you can describe it like this. So you can see it. Describe the distance time graph for a static object. It is a horizontal straight line because the distance doesn't change over time. Because as time passes, the distance will not change. Describe a distance time graph for an object which is moving with uniform motion. We will do the same. So for y-axis, we will draw the distance in meter. On the x-axis, we will draw time in second. 0, 1, 2, 3, 4, 5, 1 meter, 2 meters, 3, 4, and 5. We will use the same data So 0 and 1, this is the first order pair, 0 for time, 1 for distance. And the second order pair is 1 and 2, then 2 and 3, 3 and 4, and 4 and 5, and so on. Can you see it's represented by a straight line? But this straight line is not parallel to the x-axis. And if this object was very close to the reference point, so this means that when time was 0, there is no distance between the object and this point. So in this case, the distance will be 0. So in this case, the graph will start from the point of origin, which is 0 and 0, like this, for 1, 2, 3, 4 seconds. And we have another object which covers 10 meters every second. So 10, 20, 30, 40, then 50. So 1 and 10, 2 and 20, 3 and 30, 4 and 40, and so on. So in this case, we will have also a straight line, but this straight line will start from the point of origin because the object was exactly at the reference point. There was no distance between the object and the reference point at the beginning when time was equal 0, right? So describe the distance time graph for an uniform object is represented by a straight line which has a constant slope or gradient. This is called slope. Slope means delta y over delta x. Delta means it's pronounced as delta, and it means change. And the change means final minus initial. For example, if the final distance is 40 and the initial distance is 20, you can choose any 2 points, by the way. So it will be 40 minus 20. This is the change in y-axis or the change in distance or position over corresponding distance time, which is 4, and this one is 2, so it will be 4 minus 2. This is the change in the x-axis or change in time. So in this case, it will be 20 over 2, which will be 10. The distance is measured in meter, time is measured in second, but they are divided, so the unit will be meter per second. So this means that this object is moving with speed. V stands for velocity, okay? This object is moving with uniform speed, which is equals to 10 meters per second. This means that this object covers 10 meters every second. Okay, so let's try to copy the answer. So the question just wants to write the description for this part. So the description, it is represented by a straight line, straight line, because the object moves at a constant speed. As you can see, if you just take any point for distance, any point, and you divide just its distance by its time, you will have the same number. But on one condition, you should start from the point of origin. But if the object is not started from the point of origin, you need to use this relation because you need to find not y over x, you need to find the change in y over change in x, but this is an advanced topic, so don't worry. What is non-uniform motion? We'll take this one in a new line if we can. Okay, copy. Okay, what's meant by non-uniform motion? Non-uniform motion means that you have an object which is not covering the same distance at the same period of time. For example, if this is the reference point and you were just standing beside it, so at time equals 0, the distance between you and this reference point is just 0. After 1 second, you moved 1 meter. After another 1 second, you covered extra 2 meters. After another second, you covered extra 3 meters. So the total distance covered in the first second is 1 meter. After 2 seconds, you covered 3 meters because you covered 2, then 1, then you covered 2. Then after 3 seconds, you covered 6 meters because you covered 1 meter, then 2 meters, so the total is 3. Then you covered extra 3 meters, so the total is 6, and so on. So if you try to represent it graphically, for time axis, it will be 0, 1, 2, 3. But for the distance, which will be represented on the y-axis, it will be 1, 2, 3, 4, 5, 6. So as you can see, the first order pair is 0 and 0. The second one is 1 and 1. The third one is 2 and 3. And finally, it is 3 and 6, right? Can you see it is not straight line anymore? It is a curved line. So this means that this object is moving with non-uniform speed or velocity. And this object is speeding up. Why is speeding up? Because at the same period of time, it covered a larger or longer distance. In the first second, this object just covered 1 meter. But in the second, which is still a second, this object covered 2 meters. In the third second, which is also 1 second, this object covered 3 meters and so on. So this object is speeding up. This object is moving with non-uniform speed. Non-uniform speed. And this speed is just increasing or increases. So this is called accelerated motion, but this is advanced topic. So what is the non-uniform motion? Non-uniform motion is when the object changes its speed so it does not move at constant speed, and it's represented by broken line, curved line, but it is not a straight line. Okay, so we have finished this part. Then the second part, we will talk about force. What's meant by force? Force, if we have an object, this object has a state. What is the state of the object? The object may be static. As we said before, static means its position will not change as time passes, or it is a moving object. And if this object is moving, it may be moving with uniform speed or non-uniform speed. If you want just to change the state of the object or the shape of the object or the direction of the object, you need to apply a force. You need to apply a force on this object. So what is meant by a force? Force, it is an external factor or it is an external stimulus which tries to change the state of the object, the shape of the object, or the direction of the object, right? So what is the answer that we have? What can you write? The answer is a force is a push or a pull that can change motion or shape of the object. So if you want to change the shape of the object or the state of the object, if it's static, you want to move it, or if it is a moving object, you want to change its speed or just to stop it, you need to apply a force. Okay. The second question, give 3 real life examples for forces. And we have a lot of options. So the 3 examples of the forces that we use is gravity, pulling object down. If we have, this is the earth and this is the center of the earth. If we have an object here, this object is pulled down to the center of the earth. This is called the gravitational force, and this is the reason that we have a weight. And if the object is here, it will also be dragged to the center of the earth. And if we have an object here, this object also will be dragged to the center of the earth, and so on. So gravity is an example of force. We have gravitational force, which is pulling you to the center of the earth. Also, we have a pushing force, like pushing a door to open, and pulling a bag with your hand. You are pulling a bag. So as you can see, these 2 words, we have them in the definition of the force. A force is a push or a pull that can change the motion or the shape of the object. The third question, explain how the force can change the motion of the object or change the shape. As I told you before, if this is a static object and you have applied a force which is more than the friction force, because if this is the direction of the force, this will be the direction of the friction force. Friction force. If we have a rough surface, there will be a friction between this object and the surface. So if this force is called acting force, action, and this force is called friction. If acting force is less than the friction force, so the object will remain static. But what if the acting force is just exactly equal to the friction force, also the object will not move. But what if the acting force is more than the friction force? Then the object will move with something which is called moving force or net force or resultant force, which is equal to the difference. Why the difference? Because these two objects are pushing against each other in two opposite directions. In this case, this acting force is pushing the object to the right, and friction force is always in the opposite direction of motion. So we have to subtract them. Okay? So how can we answer this type of question? If you want to change the motion of the object, a force can start movement if we have a static object and you just push it with a force which is more than the friction force, the object will start to move, or stop the moving if the object is moving to the right and you are applying force to the left, and if this force is greater than this force, so the object will stop after covering some distance which is called stopping distance, or change the speed. If the object is moving to the right and you just apply extra force to the right, the object will speed up. If the object is moving to the right and you are giving a force to the left, the object will slow down, and so on, or change direction. If we have a car which is moving in this direction and another car just hit it, then this car will change its direction, and this one also. So this is how the force can be used to change the motion. How the force can be used to change the shape of an object? A force can stretch, squash, or bend an object, like in a spring. And this is the experiment that we will do for Hooke's law. We will have spring and we will add some masses to it, so it will there will be extension in the length of this spring. So we have changed the shape of this spring. The other task, we need to search for the unit for the force. We will know that, but this is advanced topic. Force is equal to m times a. You are not required to know this. M is the mass, a is called acceleration. You can search for it. Acceleration is just the change in the speed of the object with respect to time, the rate of change of speed or velocity. F is the force. We know that mass should be measured in kilogram and acceleration is measured in meter per second squared. So the measuring unit of force is kilogram times, which is dot, meter per means divided, second squared. This unit is equivalent to a new unit which is called Newton. And you can just write capital N. So what is the measuring unit of force? It is Newton. So this is the answer of this question. What is the measuring unit of force? The unit for measurement of force is Newton. This is how can you write it, okay? But why it's called Newton? We have a scientist who's called the father of physics. His name is Isaac Newton. So who studies forces of motion. We said that we have multiple laws. We have Newton's first law, Newton's second law, Newton's third law, and also we have a law which is called Newton's general or universal gravitational law. So this unit is called after his name, just to honor his work. What is the tool that we are using to measure the force? It's formed from spring, and then we have a hook, and in this hook you can just pull or push this part like we will do in Hooke's law. This one is called spring balance. It has multiple names. It's called force meter, spring balance. This is the way that you will answer this type of questions. Can you see? So what is the tool that we are using to measure force? It's called force meter, or it's called Newton meter, or it's called spring balance. It is used to measure the force. And the reading that you will get, for example, if you got 3, the measuring unit will be Newton because it is a force. We have a picture for it, like right here. That's it. This is called force meter, or it's called Newton meter. As you can see, it's formed mainly from spring. If you apply more force on the spring, it will extend more. And we have a pointer just to point for the reading. And this is the scale, like the parts for the ruler. And we have casing just to cover everything. Then we have this hook from which you will attach the mass that you want to find its weight. Weight is a force. Weight is a force. And it is measured in meter, in Newton. Yeah, I will just scroll up. Yeah. Weight is a force and it is measured in Newton, and it's equal to m times g. M, as we said before, is the mass, and it is measured in kilogram. And g, it is a type of acceleration, but this is due to gravity. This is the reason that it's called acceleration due to gravity. And it's constant number on Earth, but it has multiple factors that affect its value. But for year 7, it's constant. So it's just 9.8 meter per second squared, or you can approximate it to 10 meter per second squared. But in fact, there are other factors. If you are interested about this one, G is equal to G times M over R squared, where R is equal to R plus H. G is called the gravitational constant, and it is a very small number. It's 6.67 times 10 power negative 11. You are not required to know this information. M is the mass of the Earth. I think it's about 6 times 10 power 24 kilogram. Can you see? Huge. 6 followed by 24 zeros. And R, it's not the radius of the Earth. R capital is the radius of the Earth. I can't remember the number, but it's about 6,000 kilometers, something like this. And h, it is the height from the surface of the Earth or the sea level. So this means that as the height from the surface of the Earth increases, r small increases, and the acceleration due to gravity decreases. Okay, but you are not required to know this information. So draw a simple labeled sketch for the force meter. You can just draw a rectangle, and from this rectangle you can just draw this spring. Then you can add this pointer. Then you can have like a scale. You can do just 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5, like a scale. Okay, and this is the pointer. Then you will add a hook here, and it's done. So you will label this one as the spring, this one as the pointer, this is the scale, and this is the casing, and so on. So this is the diagram. This is the summary. So what's meant by a force? It is just a push or a pull. What's the measuring unit of force? It is Newton. How can you measure the force? By using a device which is called force meter or Newton's meter or spring balance. What is the main function of force? Force can be used just to change the motion or the shape. This is a quick summary. Then let's do Hooke's experiment. What is the aim of this experiment? The aim of this experiment is just to investigate how the extension, it becomes longer, of the spring changes when we apply different forces or weight. And we will learn how to calculate the weight just by multiplying the mass times g, which is the acceleration due to gravity. This is the device that we are using, and we used this before. As you can see, we have just a holder stand, and we have just fixed a ruler, and then we fixed this spring. Each spring has elasticity constant, and then we have a hook, and this hook we will attach the extra forces or weight or masses that we will add. And every time we will measure the initial extension. As you can see, the initial length was about 6 centimeter. So if after adding some weight, the extension came to this part, this one just expanded or extended to this part, so it's about 8.5. So this is not the extension. The extension, which is the change in length, is equal to the final length minus the initial length. The final length is 8.5. The initial length before adding any weight was 6. So the extension due to this weight is just 2.5 centimeter. This is how can you calculate it. Okay. And if you just add extra weight and the final extension became 15, so the new extension will be the new length minus the original length. The new length is 15, the original length is 6, so the total extension due to the total force is 9, and so on. So this is the tools that we are using, and these are the steps. So what are the steps? So give me a minute. I can just prepare a video for you. Yeah, give me a minute. Yeah, this video.
What we do. So here we have a hanging spring, and what you're going to do is you're going to add mass to the spring and measure how far the spring stretches. The spring stretches because the force is acting on it.
Right, so if I'm doing all the hard work over here and the heavy lifting, what are you doing?
Well, I've got a graph to plot, Gavin, and I'm also...
What we doing?
So here we have a hanging spring, and...
Okay, so I think it's clear right now. You have a spring and you will add extra masses to it, and each time you will measure the extension, the total extension due to the total mass that you have. So what we'll do, these are the steps. You will measure the original length of the spring, which is X node for initial. You will hang a small mass, for example, 50 gram. You will measure the new length, which is just X. You will calculate the extension. How can you calculate the extension? By subtracting the new length, which is this one, minus the original length, which you have calculated from this one. Then you will repeat with larger mass, like 100, 150, and so on. Then you will record your result in a table. And this is different pictures or images for this. So we want to see, does the extension increases as force increases? Of course. The extension increases as we add more force. So in this case, there is a direct relation between them because they are changing with the same number, with a constant rate, with a constant ratio, not with the same number. Okay? Is the graph straight line? Yeah, we will discover that if we just draw the relation between the force and the extension, we will discover that we will have a straight line. This represents that there is a direct relation between them. Direct relation means if this one increases by 1 and force increased by 50, so if the force is doubled to 100, the extension will be doubled. From 1 it will be 2, and so on. Now we are trying to explain what's meant by direct proportional. Direct proportional. In this case, we will write that displacement is directly proportional to force. This means that if the force is doubled, the extension will be doubled, and so on. So, what's meant by direct proportional? Directly proportional. If two quantities are directly proportional, this means that when one of them is doubled, you multiply it by 2, the other also will be doubled. And it will be represented by a straight line. And if you find the slope or the gradient, which is equal to delta y over delta x or rise over run, you will find that this slope is equal to constant number. So the slope of this point will be the same as this point, at this point, at this point. And you will discover that the formula or the equation that we can use to verify Hooke's law, force is directly proportional to x, and since the slope of this is a constant number, we called it k. And we will discover that this force is negative. Negative means it is in the opposite direction. So if the extension is downward, the direction of this force is upward. This is called restoring force. Restoring force, it means it tries to restore the shape, the original shape of the object. You are falling down, it will try to push the spring up. So negative shows the force is a restoring force in the opposite direction of displacement. Okay, so this is the mathematical formula for Hooke's law. X is the extension. K is called spring constant. And as you can see, it differs from one spring to another according to the material and other factors. Negative means if the spring is moving down, this is a restoring force which tries to push it to its original force. So this object is moving down, so the force is trying to push it back up. So I think now you can tell me what does the term directly proportional means. Directly proportional means if a physical quantity increases, the other quantity will increase by the same ratio. So how can you write this? I will copy it here. So direct proportional, it means when one quantity increases, the other increases in the same ratio. And the graph is a straight line passing through the point of origin. This means that if we draw the relation between force and the extension, it will be straight line. Since if we divide every force by its corresponding extension, we will get the same number, which is the spring constant, because as you can, we will do it mathematically. F is equal to negative, we can just ignore this negative, k times x, if you move x to the other side by division, so f over x, which is equal to the slope, or the change in the force, is equal to the change in the extension, will be equal to k, which is the spring constant. Write down Hooke's formula or equation. The equation is F is equal to negative k times x. F is the applied force, x is the extension, k is the spring constant. Identify the independent variable. What's meant by independent variable? The variable that we can change. As you can see, every time we will add 50 gram, then 100 gram, then 150 gram, and so on. So we are changing the mass. So we are controlling the mass or the weight or the force. So the independent variable is the force or the weight, which is equal to m times g. What is the dependent variable? Dependent variable is the quantity that we are measuring. Every time we are measuring the extension of the spring, the increase in its length, right? So this is the dependent variable. It depends on the independent variable that you are changing. So the dependent variable is the extension of the spring, which is delta x or x, but the dependent variable is force. What is the control variable? The variable that you are trying to keep it the same through the whole experiment. This is the control variable. You are using the same spring. So I told you before, each spring has its own constant. The same measuring ruler, because there is error in measurement due to the measuring tool. And you are using the same starting length. For example, it was 6 centimeter on one of the images, must be kept the same. So you have the same initial value, because if you try to measure the extension, you do the new length minus the original length. So this starting length should be the same. Okay, so we will do the calculations. As you can see, how can we convert the mass from gram into kilogram? Just by dividing this by 1000. So 50 divided by 1000, you need to write the steps. It will be 0.05 or 0.050. It is the same. 100 divided by 1000, it will be 0.1, 0.10, 0.100, the same. 150 divided by 1000, it will be 0.15, 0.150, the same. 200 divided by 100, it will be 0.2, 0.20, 0.200. 250 divided by 100, 1000, it will be 0.25, 0.250, it doesn't matter. How can you calculate the weight by using the mass? The formula is weight, which is force, gravitational force, is equal to m, which is the mass, times g, which is 9.8. So you will do 0.05 times 9.8, 0.1 times 9.8, 0.15 times 9.8, 0.2 times 9.8, and finally 0.25 times 9.8. I think I have a calculator here. Yeah. So 0.05 times 9.8, 9.8. So it will be 0.40. We can use different color. 0.49. And of course, the unit is Newton. Okay. Then 0.1 times 9.8, it will be 0.98 Newton. And here we will have 0.15 times 9.8. You can do times 10 for simplicity. 1.47 Newton. Here we have 0.2 times 9.8. So it will be 1.96 Newton. And finally, 0.25 times 9.8, it will be 2.45 Newton. Okay. Then, how can you convert the extension from centimeter, because we are using ruler, which is measuring length in centimeter, into meter? You just divide by 100 because each 1 meter contains 100 centimeter. So you will do each length divided by 100. So 2 divided by 100 is 0.02, 0.04, 0.06, 0.08, 0.10, or 0.1, it doesn't matter. So what we'll do right now, this is the extension which represents delta x, and this is the force which represents the F. So this is the two quantities that we need to represent the relation between them. So this is the force which will be drawn on the y-axis, and this is the extension which will be drawn on over the x-axis. So for displacement, we have 0.02, 0.04, 0.06, 0.08, and 1. And for the force, we have 0.49 Newton, 0.98, 1.47, 1.96, and finally we have 2.45. This is the only two variables that we are interested about. So these are the steps. Convert mass from gram into kilogram, done. Calculate the weight by multiplying the mass times the acceleration due to gravity, done. Convert the extension from centimeter to meter, done. Draw the graph between force and extension, not done yet. And then we have some questions. So let's do it. So this is the example. How can we do this? You need to use your ruler just to draw a straight line. I think I can use, yeah. So from here, we will draw just a straight line. This represents x-axis, and then we can have another straight line which represents the y-axis, or just array. So over y-axis we will put force, which represents the weight in Newton, and over x-axis, this is the y-axis, okay? Over x-axis we will just add the extension in meter. According to the data that we have, for the extension we have 0.02, 0.02, and we are moving each 0.02 or each 2 centimeters. So 0.04, then we have 0.06, 0.08. Your scale should be uniform. You are moving the same steps, 0.1. For the weight, as you can see, it's hard to be drawn. In fact, it's 0.49, which is almost 0.5, 0.98, which is almost 1, and so on. So I will move every half. So half, then 1, 1.5, then 2, then 2.5. Just a little bit of acceptable approximation. The first order pair, as you can see, it's 0.2 and 0.49, which is very close to 0.5, which is 0.50. So this point will not be here. So we will imagine that it's just there. And the second point is 0.04 and 0.98. 98 is very close to 1, so just a little bit under it. 0.06 with, I think, 1.47. Yeah, it's 1.47, which is very close from 1.5, which is here. So we will move just a little bit under it. 0.08 is 1.96. So 1.96 is very close to 2 here. So we'll just move a little bit under it. Finally, 0.1 or 0.10, 2.45, which is very close from 2.45, which is very close to 2.5. So it's just a little bit below it. As you can see, if you just use your ruler and try to join the points like this, we will see that we have straight line. And if we just extend this straight line, we will figure that it will start from the point of origin. And if we can extend it from this side, we can predict other points, by the way, like this. For example, how can you predict other points? For example, if I'm asking you what will be the force or the weight which will cause the extension of the spring by 12 centimeter. 12 centimeter is here, which is just 0.12. So you will go there to this point, then you will move to this side. So I think it will be very close to 3, just a little bit under it. But if the mass just exceeded the elasticity of the spring, the curve will not be straight line anymore. Okay, and the force will not be able to restore the spring to its original shape, because the limits, you have exceeded the limits. Okay, so now we can move back. For this part, draw, we just represent the relation graphically. Is the graph straight line? Yeah. Yes. Does it verifies Hooke's law? Yeah, it verifies Hooke's law. Why? Because force is equal to negative k. Xk is just a constant. So this means that if you just increase the force, which is the weight, the extension will increase by a constant value, which is the slope, which is the spring constant, right? So this proves that displacement and force are directly proportional, and this is the main target of Hooke's law. State whether the relation is direct proportion. Yeah, it's direct proportion. But how can we answer these two questions? How can we write the answer? So for the fifth question, for question 5, this one, the answer is yes. If the graph is a straight line through the origin, it verifies Hooke's law. For the question 6, is the relation between force and displacement or extension is direct relation? Yeah, because as force increases, the extension increases proportionally. And these are the steps. Can you see? We have this is example just to help you. We divided the mass by 1000 to convert it from gram into kilogram. Then we multiplied it by the acceleration due to gravity, which is 9.8, just to find the weight. Then we just took the extension and divided by 100 to convert it from centi into meter. Then we draw the relation between force and extension, right? This is the example. And this is the graph. And we represented extension over the x-axis and force over y-axis, and this is example of the order pair. So for this one, as the force increases, the extension increases because force and displacement are direct proportional, and the graph is represented by a straight line, and there is a direct relation between force and displacement. This is your feedback. So according to your degree of understanding after having this session and the task that we had over Teams, you can just say, I understand what's meant by force. What's meant by force? It is a push or pull, or it is an external factor which tries to change the shape or the motion of the object. I correctly converted from gram into kilogram. How can you do this? Just by dividing the mass in gram by 1000. I correctly calculated the weight. How can you do this? You will take the mass in kilogram and multiply it by 9.8, which is the acceleration due to gravity. I converted extension from centimeter to meter. How can we do this? Just by taking the length in centimeter and divide it by 100. I drew the graph neatly using ruler. We have done this using computer. My graph shows a straight line. If it's done, you will say yes. If it's no, you will say no, and you will do some more practice. I labeled both axes. X-axis represents the extension in meter, and y-axis represents the force or the weight in Newton. What can you do just to improve your work? I need more practice with unit conversion. If this is true, you can just invent some numbers. You will say, what if the mass is 10 gram? What if the mass is 20 gram? What if the mass is 50 gram? And how can I convert it into kilogram? You will say just by dividing by 100. So this one will be 1000. 10 divided by 1000, it will be 0.01, 0.02, 0.05, and so on. So in this case, you will do some practice. If not, you will say, no, I'm qualified in this point. I need more practice for force equal mg. If you want to calculate the weight, you will take the mass after conversion into kilogram and you multiply it by g, which is 9.8. So in the first example, you will do 0.01 times 9.8, and you will do the calculation 0.02 times 9.8, and you will do the calculations and so on. If you are okay, you say no, I don't need. I need to improve my graph skills. Maybe you are not satisfied with the graph that you just draw, so you need to have more practice. So in this case, how can you do this? You can just draw a table and you will add force and extension. For example, for extension, make it simple. For example, 5, 10, 20, no, 15. Just move with constant steps, and later on I will tell you how move in a strange numbers. And for force, maybe it's 100, then double it, because you have doubled the extension. So it's 200, then 300, then 400, then 500. Then on a graph paper, just draw the extension over the x-axis and force or weight over y-axis. Then here add 0, 5, 10, 15, and so on for extension. But this should be in meter. Okay, just use these numbers instead of decimal, because you are trying to practice how to draw a clear graph. We are not interested about the numbers. Okay, so this one is 100, this is 200, and so on. So the first order pair is 5 and 100, 10 and 200, and so on. So you should get a straight line. If it's okay, you will say no, I don't need. I need to show my work more clearly. I think a lot of us needs to do this. I need to improve my scientific explanation. Yeah, maybe. I need to manage my time better, because it seemed that you couldn't finish the task on time. I took more time like this. It's 53, but as you can see, I'm explaining this to you. Okay, then you will try to just to specify what is the level of understanding that you are currently at. If you can just, you remember the first page, if you can just define what's meant by static and moving object, if you can just describe the distance time graph for static and moving object, if you can just mention that Newton is the measuring unit of force, and you can calculate the weight by using m times g, and you can identify the independent, dependent, and variables. So in this case, you will choose core. But if you can compare between distance time graphs of static and moving objects, if you can convert mass from gram into kilogram, if you can calculate the weight, if you can convert the length from centimeter into meter, if you can draw the graph between extension and force, then it's developed. If you can explain why the straight line explains or verifies Hooke's law, and what happens if you added more masses than the spring can handle or exceeds its elastic limit, the shape will not be restored, right? And the straight line will not be straight anymore. Describe how the error in measurement could affect the result, and you understand that the slope of the force extension graph for Hooke's experiment gives spring constant, which is different from one spring to another, and you know what will happen if you just keep increasing the mass. In this case, your level of understanding is just stretch. You can just apply it, apply what you have learned over other topics, right? So this one is different from one to one. It's up to you. And then you can tell us what you need just to improve. Okay? Just use this video to study and bring the PDF that you answered before and just check your understanding and add some notes. Use your book just to add some notes because we are doing the same for the coming topics. Okay? Bye bye.